Our lives are crammed full with hidden science marvels. All around us, biology, chemistry and physics combine and connect to shape the world we live in. But these complex processes remain invisible to the naked eye. Using thermal imaging, high-speed cameras running at thousands of frames per second, time-lapse and macro photography, special cameras unravel the mysteries of our daily lives. So what invisible processes are at work when we're cleaning? Hair in the plug hole, lime scale on the shower hose, on tiles and fittings, urine scale in the toilet, lime scale in the drain, and mold on the tile grouting. This bathroom needs some attention, but not using this old rag. Under the microscope, the ingrained dirt becomes even more visible. Every square centimetre of this dirty cloth is home to around 100 million bacteria. It should be discarded after its second use. Luckily, there are cleaners for every imaginable kind of dirt. Power cleaners, grease removers, limescale cleaners, cream cleansers, drain clearers, mold removers. But do you really need all of these? In fact, just a few basic ingredients are enough for perfect bathroom hygiene. Your grandmother probably used to use them. The first challenge, how to get rid of these fat stains. Water alone isn't enough. The fat simply smears across the surface. Hardly surprising, as fat and water don't mix. But just 3 squirts of washing up liquid in a litre of water can do the trick. Be careful though, many cleaning products can damage the skin, so rubber gloves are a must. It's best to apply the mixture using a spray. The surfactants in the washing up liquid bind the fat molecules to the water molecules and so dissolve the fat. Now you can simply wipe the fatty dirt off. So, washing up liquid binds fat and water. But what about limescale on bathroom fittings? Can it also be removed with washing up liquid? Here, no amount of scrubbing will help. On the contrary, a scouring pad will just scratch the surface of the fittings. The rough side of the sponge is made up of fine steel threads. But citric acid is effective when dealing with limescale. You can get it at a drugstore. Add 2 tablespoons to a bucket of water and get to work with a soft toothbrush. The acid dissolves the limescale into the water-soluble calcium citrate, CO2 and water. This homemade universal cleaner can tackle virtually the entire bathroom. There's a special trick for really persistent dirt. Use salt instead of a cream cleanser. The salt crystals rub down the limescale crust. Then there's the old problem of cleaning the toilet. The brush hardly touches the urine scale below the rim. There's a simple solution. Dip some toilet paper into the cleaning liquid and push it under the rim. Now let time do the work for you. Half an hour should be enough. If you've got a blocked drain, be careful with chemical drain cleaners. When combined with water, they produce a very caustic solution. It's a chemical reaction that produces extreme temperatures. A thermal imaging camera can measure them. It shows how the substances in the drain reach a heat of 90 Celsius. Temperatures like these can melt synthetic pipes. They also produce toxic ammonia, always accompanied by a severe smell. A better idea is to drop a few spoons of ordinary sodium carbonate or washing soda into the drain and wait. It may take a little longer, but there are no unwanted side effects. Now a plunger can remove the annoying blockage with ease. Mold loves to grow in silicone grouting. Magnified 50 times, it still looks horrible. But magnified by 3000, it becomes delicate abstract works of art. The mold's filaments penetrate the silicone, allowing it to spread right through the bathroom. It can cause allergic reactions and even lung damage. Again, washing soda works to tackle surface mold. Used as a strong solution, it will kill the microorganisms. But to prevent the mold in the first place, always wipe surfaces dry and air the bathroom regularly. So, it's really quite simple. Washing up liquid, citric acid, salt and washing soda are all that's needed to effectively clean the bathroom. And if you do it regularly, you'll have less work in the long run. In the future, the bathroom itself may assist in our cleaning endeavours, thanks to nanotechnology. Tiles with a dirt and water-repellent coating don't allow dirt to get stuck to them in the first place. The water molecules form a droplet, which encases the dirt. But to avoid working too hard, teamwork is the key. Removing stains from a fabric is a tough challenge. What's more effective? Established tradition or modern science? Which products work and which are useless? The duel is fought between traditional household remedies and specialist stain removers. Fat stains are our first challenge. The mayonnaise gets right into the fabric of the t-shirt. Magnified 50 times, we can see how it penetrates the fibres. Bile soap is an established treatment for fat stains. It contains surfactants. Surfactants bond with fat as well as water, so they can form bridges between them. It means the fat can be removed from the fabric. So how does the modern stain remover fare? The specialist cleaner also relies on surfactants to combat the fat. The treatment is successful. Whether in bile soap or in specialist stain removers, surfactants can deal with fatty stains. Round 2. Ketchup stains. The red pigments are carotenoids, and these are fat-soluble. So once again, the surfactants are effective. Bile soap contains certain acids that support the work of the surfactants. Bile soap is an effective treatment for many other fruit and vegetable stains. The specialist stain remover is also a success. So far, the duel is undecided. Now it gets bloody. Hemoglobin is the red colour pigment in blood. It's a protein. An important thing to remember with any protein-based stain is to rinse them out with cold water. Fresh blood stains disappear simply by quickly washing the fabric in cold water. Warm water, on the other hand, only makes things worse. The warmth changes the proteins in the blood, and they cling to the fabric with determination. Luckily, there are also special stain removers to treat blood stains. They contain enzymes, which divide proteins, as seen here in time-lapse. Red wine stains are a classic nuisance and are the ultimate challenge for a stain remover. The red colour pigments in wine are anthocyanins, and they stick more forcefully to fabric fibres than the carotenoids in ketchup because they're more strongly charged. Salt is a well-known household remedy for tackling red wine stains. The specialist stain remover is also made up of light-coloured granules. But which method is most successful? The specialist stain remover on the left seems to be far more effective than normal cooking salt. The active ingredient is a bleaching agent that works on an oxygen basis. The atomic oxygen destroys the wine's colour pigments, here in time-lapse under a microscope. Cooking salt to tackle red wine? Well, that appears to be an old wives' tale. Lemon juice is another common recommendation, but the acid in lemon juice only causes a change in the colour. The stain remains. The red colour pigments of the wine aren't fat-soluble, so the soap surfactants are ineffective here. Stains from beetroot or red berries also usually require treatment with bleaching agents. So some stains can only be treated with specialist cleaning products. But in most cases, the old tried and tested household remedies work at least as well as the new specialist cleaning products. And these are much more expensive and often less environmentally friendly. Anyway, who says you have to get rid of all the stains? Dust gets everywhere, especially if you look at it closely. Special cameras reveal a collection of different shapes and sizes. When magnified, these dust particles look like an alien universe of planets and mysterious creatures. But these miniature structures just aren't tolerated during the manufacture of electronic components in clean rooms. Dust particles just 1/1000th of a millimetre can be detrimental here. Dust is rarely a health risk at home, but it's still got to go. The vacuum cleaner deals with the rough stuff. So what is household dust actually made of? A magnifying glass isn't enough. It calls for a specialist microscope. About 20% of this dust is made up of food crumbs. The biggest share, about 70%, is textile fibres from clothes and carpets. And the remaining 10% is a mixture of mostly hair and flakes of dead skin. So we actually produce most of the dust ourselves. We're veritable dust factories. Every day we shed more than 50 grams of textile fibres and lose around 100 hairs. And we produce about half a kilogram of skin flakes a year. Perfect food for dust mites. In just a single day, we lose enough skin flakes to feed around 1.5 million of them. To work in a clean room, each human dust ball has to cover up in elaborate suits and clean their shoes with adhesive tape. At home, the vacuum cleaner sucks up the larger dust particles, but then sets most of the fine dust free again. Fine dust is particles more than 1/10,000th of a millimetre. Here, they've been slowed down 200 times. This fine dust is often from natural sources and comes from outside. Some of it's travelled a long way. This grain of sand started in the Sahara Desert. These silicon compounds are so light that desert storms can push them high up into the stratosphere, where they're carried for thousands of kilometres from Africa to other continents. Tiny dust particles, only visible when magnified 40,000 times, can also infiltrate the home through windows. Soot from chimneys and car exhausts. Plant pollen. Even salt crystals from the ocean. They all become part of the eclectic mix that make up our household dust. As ironic as it seems, the oceans are the greatest producer of dust on Earth. The clean room is kept at positive pressure, and that ensures that the dust stays outside. Air is filtered through these fine-pored mats made from a fine fleece material. In the clean room, 1 particle of dust per litre of air is the limit. But at home, it tends to be more than 1 billion particles. Wiping surfaces with a wet cloth helps get on top of this fine dust. The particles are caught in the water droplets and can be wiped off rather than smeared around. Wiping the surfaces dry afterwards removes the dust, together with the film of water. The same goes for the floor. After vacuuming, clean the floors with a wet cloth. Anywhere that shouldn't be treated with a damp cloth can be cleaned with a microfiber cloth. Its large surface area allows the fabric to collect even very fine dust particles. Magnified 100 times, its super dense fibres become visible. Inaccessible places can be cleaned with a duster. The friction provides an electrostatic charge, which attracts dust particles. This too can only be seen clearly under a microscope. Even with the greatest of care, it isn't possible to keep the clean room dust-free. Cleaning is just like at home, but it's slow and meticulous. Even so, there simply isn't an entirely dust-free room on Earth. And dust isn't all bad. It's home to microbes that train our immune systems. So overdoing the hygiene thing can encourage allergies and make life fairly uncomfortable. These windows are in need of a good clean. Are traditional household remedies up to the job? A 10% solution of ammonia tackles the dirt. It's more effective with warm water, which helps to dissolve the grime on the window pane. Windows seem to attract dirt as if by magic. On the left is the cross-section of a window. The ammonia solution gives the glass and the dirt a negative electrostatic charge, so the dirt gets repelled from the glass. Modern cleaning products have the same effect. A professional window cleaner always washes the dissolved dirt particles off the window before using a squeegee to dry the surface. But what about limescale? An old recipe suggests using a cold vinegar-water mixture to follow the cleaning phase. Limescale consists of calcium and carbonic acid. Acetic acid or vinegar is stronger than carbonic acid, so it can penetrate the limescale. A high-speed camera running at 200 frames a second reveals the processes at work. An absorbent wash leather is best to dry the windows afterwards. Yet still, tiny water droplets escape. They dry very quickly and leave small stains on the glass. To avoid such setbacks, the professional uses a squeegee. The glass has to be really wet to allow the squeegee to push a wave of water in front of it. It washes the dirt off the window. The squeegee is thorough and leaves no water droplets behind it. A high-speed camera running at 200 frames a second can show the processes in detail. Newspaper is an old household tip for drying windows. It absorbs the last water droplets and is said to give the glass a particular shine. That's because both newsprint and windows used to contain lead, which used to produce a fresh lead shine. Today, the painstaking polishing with newspaper is a thing of the past. Magnifying the process 150 times, we can see how a microfiber cloth does a much better job than the paper cellulose ever could. Its many tiny fibers are shown on the left and can absorb a lot more water. There's one golden rule: never use a scouring pad to deal with tough stains. It may contain metal fibers and can scratch the glass surface. A microscope reveals the metal fibers that make up roughly 40% of the scouring pad. The remaining 60% are synthetic materials. The scouring pad leaves behind ugly scratches. They're not easily seen with the naked eye, but when magnified 50 times, they look like a miniature Milky Way. So why does dirt stick so stubbornly to glass? It's a smooth surface, so surely dirt shouldn't really stick to it. An electron microscope exposes the glass pane as anything but smooth. Magnified 10,000 times, its surface looks more like a landscape of hills and valleys. It's created when the main raw material, quartz sand, and the added chemicals bond together. And these valleys are excellent places for dust and dirt particles to get a foothold. Encrusted dirt is best removed using a scraper made for ceramic glass hobs or a special cleaning pad. A professional window cleaner has to do one thing above all else: make good headway. On average, they have to clean thousands of square meters of glass every year. So, to clean windows properly, you should add an ammonia-based cleaning product to warm water. Use a sponge to generously wet the window pane. Spray it with a vinegar solution and quickly follow up with an absorbent wash leather and then a microfiber cloth. Finished. And you see, you don't even have to be a professional.